Let's try to understand the implementation of PID in form of a graph. Let's compare the performances of P, PI, and PID controllers. So if we just look at the P controller, where this KP is implemented, which is denoted by a maroon line, which is this one, we can see the system overshoots a bit, but in this example, it starts to undershoot later on and is never able to reach the desired value or to the set point. But if we look at the Kp plus Ki, that is the Pi implementation, which is denoted by this orange graph, we can certainly see that the system overshoots, but is able to reach towards the set point after a certain point in time and saturates out towards the desired value. That is, the error becomes minimal or becomes zero after some point of time. Now, in comparison to these two controllers, P and PI, what we can now see is for PIDs denoted by the pink line, we can see that the system does overshoot a bit, but the overshoot is less in comparison to both the P and the PI controller. And it tries to reach towards the desired point or towards the set point pretty quicker in comparison to both the other controllers. This graph simply shows how a PID controller actually performs better than a P or a PI controller. Yes, this might differ with different systems with different values of P, I, and D, but this needs to be checked out, and the performance of the system will be very different for different values